Hello, biology. Um, in this video, I will go over the Wisconsin Fast Plant Lab report and what I expect from you. And then I will complete an example calculation that is pretty similar to the ones you'll have to do for your actual lab report. And it'll kind of give you a model to kind of work off of. Let me share my screen for you. Great. So this is what you'll see assigned to you. I've done some things for you that you would traditionally had to do in the lab report to make this process go a bit more smoothly this year. I've already wrote the introduction for you. You can read through that. It will kind of give you some hints going forward. But for this lab report, we're going to test two different null hypotheses. There's one here where you're going to test the null hypothesis for the Petri dish data, and then the soil data for stem color. Below in the data section, I've created a calculation data for the Petri dish and for the soil, which you can complete just like my example or just like in your homework last week. And I'll show how to do that. So you just have to complete the table, calculate your chi-squared value by adding these two numbers together. And then finally, you're going to do a data and error analysis where you restate each null hypothesis and evaluate it against the critical value of 3.841 to either accept or reject each null hypothesis. Remember, if your chi-squared value is below 3.841, you're going to accept that null hypothesis. That's good. There's no statistically significant difference between observed and expected. Awesome. But if it's above, you have to reject it. There's something going on. There's some error here that we're not taking into account. And then finally, I want you to comment on possible error that you may see in the lab and the results of each test. So just a couple written sentences about each result, and that will be great. So that's what you have to do. Let me do an example for you to kind of make this a little bit easier. So this is your data. Here's where you'll be pulling the Petri dish totals. Down at the bottom here. Here's where you'll be pulling the soil totals. I'm going to use these all plants, though, just as an example for you. So the null hypothesis that I'm going to test, which is different than what you're going to have to do, is that there is no statistically significant difference between the observed and expected frequencies for just stem color. Not talking about soil or Petri dish. I actually combine them both together to complete this one. So let me grab my observed results first. So for purple, I have 769. And for non-purple, I have 287. Now, whenever you're looking at an F2 generation for this dominant recessive inheritance pattern, you expect 75% to show the dominant trait and 25% to show the recessive trait. So I need 75% of this total. So I need to take 75% of 1,056. If I put that in my calculator, I get 792. If I go 1,056 times 25% or 0.25, I get 264. So this expected is what I expect based on the 75%, 25% from my F2 generation that I got using the Punnett square. Now, O minus E negative 23, 287 minus 264, 23. Great. All right. Now I have to square 23. Gets rid of the negative sign. Whenever you square a negative, you get rid of the negative. I got 529. This one happened to be 23 too by coincidence. 529. Then I do O minus E squared divided by E. So here I get 529 divided by 792 to get 0.67. I am rounding here to the hundredths. That's good enough. And 529 divided by 264. And I get 2.00. Great. To get the chi-squared value, I add them together. So I get 2.67, which I'm comparing to my critical value, which is 3.841. So if it's below, I accept. If it's above, I reject. So in this case, I am gladly going to accept this null hypothesis that there is no statistically significant difference between what I observed, the data that I collected for purple and non-purple, and the expected frequencies from the Punnett square for stem color. Awesome result. So hopefully that's a good example for you that will allow you to now do this for the Petri dish and soil separately to see if you're going to accept or reject those null hypotheses. If you have any questions, let me know. But besides that, let me stop sharing my screen and say good luck to you.